Hello, my name is Jaimmy Cervantes. This is Adrian Arroyo and Jonathan Vega, and we are the LumCycle team. We will be presenting what the LumCycle is, how it works, and how we'll implement the community worldwide. So what is the LumCycle? The LumCycle is basically a kit that we will be selling for bicycles, and it will be installed on universal bicycles. They will be able to charge electronic devices and provide boosts to the cyclists. This is going to have an easy install on all the bicycles that we're trying to implement for it to be for any bicycle. It will contain an alternator that converts mechanical energy to electrical energy, and all electrical energy can be used at the rider's discretion, so it could charge phones, charge GPS devices, and also the rider can have a boost from the motor.
So our project description, what we're trying to accomplish with the LumCycle is first of all to charge many gadgets such as GPS devices, electronic devices such as iPhones, Android phones. This is crucial because in cycling expeditions, some trips may take up to 6 to 8 hours of traveling very large miles. In these trips, it is essential to have a phone charged for safety, for communication, and sometimes the cyclists don't have where to charge their devices. That's why the LumCycle is also going to provide a front and rear LED lighting system for night rides, as well as it's going to be ergonomic and lightweight, which will not hinder the rider's performance. Here in this photo is the completely first origin of the LumCycle before we began the CAD automated drawings. It's going to contain two things, a control station, which is going to be located in the handlebars, and a power station, which will be located in the rear wheel hub. The power station will consist of a generator, an alternator, and a motor, which will all work to charge the battery, which will be able to charge the outlets as well as provide the boost. Here you can see the components of everything I just mentioned in this photo. The motivation we had to create the LumCycle, all three of us, we enjoy cycling for hobbies, we go mountain biking, so we wanted to incorporate a project that we will be interested in, that we know can not only be convenient for riders, but for hobbyists as well. Also, the LumCycle will have three components, such as safety, communication, and performance, which is very important for the riders' pleasing efforts, and it will all maintain affordability and accessibility for all ages and walks of life. The LumCycle kit, as time goes on, can be catered to different types of uses. If you're a cyclist that wants more performance, it could be lighter, which will be more expensive, and if you just want a recreational boost as a normal rider, it will also be a cheaper kit as well.
Some background on information on the LumCycle. The LumCycle will be classified as an electric bike, e-bike for short, and there's two specific types of e-bikes, pedal assist and power on demand. Pedal assist, the motor is active while the rider is pedaling, and power on demand is activated on the rider's discretion, whether button or throttle. Here in figure 3 is the Audi e-bike, that one is pedal assist. Next we have the electric motor. The one we're going to be using is an electric brushless assist motor. Some background knowledge on power systems is that they're used for any pedal cycle, and especially the ones that use chain drive, belt drive, function drives, or hub motors. Here in figure 4, this is a mid-drive system. So what it is that it's the mounted towards the middle bottom bracket and not actually on the wheel itself. Next we have our electrical energy source is the lithium-ion battery. We specifically picked LIBs because we want it for its lightweight and rechargeability. It's classified as a recharge battery, so as you see in figure 5, the negative to positive electrode and vice versa allows for discharge and charge. The three main components of an LIB is the electrolytes, the positive electrodes, and the negative electrodes. Next we have our latest standards for our system level standards. We're using the NITC, the National Institute for Transportation and Communities. This is so that way we make sure we don't become like a scooter or a moped, and as far as the NITC established, we maintain our definition as an e-bike. We will also be purchasing a battery approved by the IEC, International Electrotechnical Commission, and we'll also be following other standards such as ASME, AGMA, and ANSI. Here's a list of the IEC standards in figure 6. all the ones that will be covered for sure. And figure 7 is the map of minimum age established by the NITC. So, for example, in Florida, the age of 16 is the minimum age of operation for e-bikes.
For our first alternative design, our components are on different locations of the bicycle. So for this design, we implemented the motor on the rear wheel hub, and then we have the alternator or generator on the circumference of the tire in the back, making a rotational energy to electrical energy. On the handlebars, we're going to have the control station, which you're going to charge your phone, your GPS, and your devices, and also have all the controls for the whole kit. This design was the first design, and we wanted to make everything more compact. That way it would be more allowable for install for more universal bikes. For our next design, we implemented the gears, that they're going to be like a mid-drive system in the middle of the bike. As you pedal, it's going to be charging, and also the motor is going to be giving you the boost as you want. So the design includes all the components connected to each other via gears. Gears are powered by the main pedal axis, so as you pedal, it will be charging. And we have to maintain appropriate gear ratios, as that would be very crucial for this design. For our third design, we have a power station. So all the gears and motors, the motors and alternators are all going to be compacted in a power station, so everything's going to be enclosed. We're going to be using the rear wheel diameter. They gave us the most accurate results. And this is going to be the most compact and the most efficient design. So for our final conceptual design, we wanted to keep the alternative design 3 because everything is most compact, the most efficient, is the most visually appealing, and is the easiest to implement on all all universal bicycles. So it'd be very easy to install on any bicycle. After calculations, we determined that the wheel gear diameter must be 5 times bigger than the actual motor gear.
So mobile design components we implemented within our project. We have, of course, we want to maintain the SI-US units. We, as a LmCycle team, want to not just keep it here in America, but have it engage with other countries worldwide. It's environmentally friendly, so we are not producing any waste. Nothing's gonna be, like thrown away or harming the environment. It's compatible with all universal devices, so of course we have the outlet and the USB port, so anywhere around the world, the electrical energy will be accessible, so that way we can use it for all devices. And it appeals to all cultures and people worldwide.
Some environmental issues that we will prevent with the creation of the LmCycle would be the kit will cause 0 pollution and 0 harmful tailpipe emissions, since it will not be an automobile or motorcycle. The LmCycle will also include a sealed battery, which will allow for no lead in the lead acid batteries to harm the environment. In addition, the LED lights that will be mounted on the control and power station contain 0 levels of mercury, which mercury is known to cause damage to sea life and to the water supply of the city. And LmCycle, we will also implement proper battery disposal to the customers so that we ensure that batteries are not disposed in the wrong way, which can harm rainforest or even environments such as our city. Here's an estimation of how much the kit will cost. This is the prototype, so the final cost may be different. What we reached was $378.42. Now this is a fairly economic price because there's also other bicycles in the industry, such as the Pedigo Ridge Rider, that performs the same task that the LmCycle will perform. However, that bicycle costs $3,500. This kit will cost $378. So depending on the bicycle you want to install it on, for example, if you have a mountain bike that costs $1,000 and you install the LmCycle onto it, the total price will be about $1,400, which will still be less than competitors such as the Pedigo Ridge Rider, which will make the LmCycle more appealing for customers. Here's a chart about all the different times and dates that we're going to implement our designs and our different timeline. And in conclusion, the LmCycle, we decided to tailor our current knowledge of e-bikes to improve bicycle riding for everyone. We also researched a lot about electric motors, lithium-ion batteries, and alternators, so we could design our own e-bike in an affordable kit. And related standards and economic aspects were also put into account in order to maintain a good environmental standpoint as well. Thank you. This is the LmCycle presentation. We'll happily take any questions.
First question I want to ask is on lithium-iodide battery, because I've been hearing about, and I forget what they call them, those boards that people,
Well, they're called the hoverboards.
hoverboards.
Yeah, that's the
They
name.
keep burning up, they have fires.
Yes.
Do you understand what the issue there is and what you would have to do to make sure that your system didn't fall into the same danger?
Currently, as of now, we still haven't really realized what's the problem with that. So as of now, I won't have an answer to that.
So it's a guidance to you, is to
Okay.
make sure you understand that problem,
So
to
it
make
doesn't
sure
happen.
you've got circuit safeguards to prevent ever getting into a scenario where you overheat,
All right.
burn out that battery.
Thank you very much.
Okay, that was the first one. Second one, on your costing, you had things on there like soldering iron and solder. The
Yes.
actual cost is just the cost of solder. What it costs for the materials and stuff, the equipment you need to produce, so you can actually bring your price down,
Even
All right.
even lower than it is today.
Thank you.
Other comments to the team?
So how do you actually envision this interfacing with the gearing mechanism on the wheel? Are we adding a component to the chain path? Are we applying it directly to fix to the wheel?
Yeah, so.
How are we interfacing?
So, right here, this is going to be connected to the, this will be connected to the rear wheel, and here is the bicycle. So this would be, as this moves, you have the alternating motor.
So it's not in the gear train.
No, this is not with the chain. This is with the rear wheel. Any more questions or comments?
I really like your presentation. I mean, from the other groups, you guys actually had all the figures labeled, easy to read, nice to the point. You guys did a good job with that.
Thank you.
Any more questions? Comments? Tips?
Finish early, you get data. That's the tip.
So in your,
Maintain the deadlines.
well,
Data and analyze it.
well, and in your case, what's probably the most important is feedback, user feedback. Because I think as absolutely it has to be able to charge, but you're also going to want writer feedback on it.
All right. Thank you very much for your time.
Thank you.
Thank you, Team 8. Now we're moving on to team number 9.